Hello and welcome back to my favorite people, and thank you very much for watching this lecture video. I'm going to go through thiols and sulfide. And when it comes to thiols are an analog of alcohol. We will have SH instead of alcohol. And I want to remind you like how actually we named alcohol. We said the priority it will go to OH. So this is going to be the first carbon, 2, 3, and 4. On the third carbon, we have methyl. So we say 3-methyl. And then we have 4 carbons. So our main chain or the parent chain, it has 4 carbon. This one is going to be 1, and then it will be 3-methyl, and then we can say 1 butanol. No, okay. Or we can say this. We can say 3-methyl, and then say butane, and then say dash 1 dash, and then we say OL to show position of the OH groups. So technically, instead of E at the end of the name, we replace it by OL to say that we have alcohol. Now, when it comes to thiols, and the way we're going to name it, it will be exactly similar to the alcohol, but the only difference between them, the OL will be replaced by the thiol. Okay, so we say 3-methyl, and then we say 1-butane. Listen carefully, butane, and then we say at the end we're going to add the thiol to the end of the name. Be careful about this. And or we can say 3-methyl, and then say butane dash. Now we say 1, okay, and we have thiol. So now we say thiol. Okay, and so we kept the E. We did not remove the E from end of the name. So thiols have SH instead of OH in alcohol. Okay, and sometimes also we call thiols, and we call them mercaptans, and so we can use it actually as a prefix to name the compound. So for instance, in this case, we have 1, 2, 3, and 4. So the main chain, it will be this one is a butane. We have 2 substituents. One substituent will be SH, and the second one is methyl. So we have mercapto, Me, and then R versus methyl. So the mercapto, it will get priority over the methyl. And where is it? It's sitting on the third carbon. So I'm going to say this is going to be 3-mercapto, and then I say 3-methyl. And where is OH on the first carbon? So I can say 1-propanol. Okay, that's one way to name it. Another way to name it, just copy paste this and change position of the technically the OL. Okay, OL in here 1. So I'm gonna just simply get rid of this part 1 and OL. Move this one here. So let me change the color for it, so then you can track what I did. Okay, so propane. Okay, E, I got rid of the E, and now I say dash 1 dash OL, and that's another way to name it. Okay, and the second compound, it has 2 SHs, and again the priority it will go with alcohol. So we go 1, 2, 3. I have 2 substituents, 1 and 2, and so I'm going to say this is going to be 1 and 3 di, and then I say mercapto, and then I say on the first carbon, I have OH, so it will be 1-propanol. We can repeat the same thing like in the previous actual example, and change position of 1 and also the OL. So I can just simply copy paste this one. Okay, and say this is gone now. Okay, and also the OL is gone. I'm going to move this one, attach it to mercapto, change the color. Okay, next I say dash 1 dash OL to show that we have alcohol and it's sitting on the first carbon. Okay, and we use actually this compound to treat mercury poison. The reason for it is sulfur has high tendency to react with mercury, and it can actually take mercury. Or and if you spill mercury on the surface, always we dump a bunch of sulfur on the top of it. Sulfur, it will have a good reaction with mercury, and it will collect technically mercury, and it will be easy to clean the surface. thiols, and we're talking about thiols and sulfides. The thiols, we know they have a really bad smell, and one well-known actually animal that it has such a like it has a thiol, and is in the skunk. They use it as a defense mechanism, and also we use this compound methane CH3 attached to SH. And we add this compound to natural gases, so then we can track any leakage. And so the methane by itself, it doesn't have much smell. And in order to figure whether there is a leakage or not, or easier to find that leakage, we add the sulfur compound to it, so it will be easy to track it. Okay. Now SH, and if this one gives an H, it will turn to CH3, and then S with 3 lone pairs. This one will have a negative charge plus H plus. The S minus, okay, is stable enough, but it's a weak, okay, it's a weak acid, okay, because it's a weak acid, it will give us a conjugate base. A conjugate base, it will be a strong conjugate base, and like an or a strong nucleophile, okay. And when I say it's stable enough, I'm comparing it, versus OH. Okay, and SH is more, and like it's more acidic than water. That means the conjugate base of SH, it will be more stable than the OH. Okay, they can get involved in the SN2 reactions. They, like also E2, but as you see it written in the slide, it says they will prefer to go through SN2. It doesn't mean that we were not going to see a E2 product. Okay. One example, I have a metal, and a metal, it will have a positive charge. That means SH, it will have negative charge. So what will happen? We will have SN2 reaction. This carbon is a primary carbon, and bromide will be kicked out of the system, and it will be replaced by SH. And also we get bromide with a negative charge. So this is really basic SN1 reaction. Now, if you're dealing with a secondary carbon, that secondary carbon, again, it can get involved in SN2 reaction, and we will get such a product. So now, because bromide was facing to us, the SH in this case, it will be back of the molecule, and we will have inversion with the stereocenter. Okay, so there will be inversion because it's a SN2 reaction. Now, thiols can be oxidized, and if you oxidize them, you will get disulfide. Okay. Before I go through the chemical reaction, I want to actually show you the difference between thiols and sulfide. Thiols, we will have R attached to S, and S is going to be attached to one H. So under any condition, there will be one H attached to sulfur. Okay. Now, when it comes to sulfide, this one I'm going to call it a thiol. Okay. When it comes to sulfide, there will be a sulfur, but that sulfur, it will be attached to 2 carbons. Okay, 2 R or 2 alkyl groups. There is no H directly attached to sulfur. And this one, we call it sulfide. Okay, so for example, dimethyl or diethyl sulfide. Okay, now, and as I said, we can oxidize thiols. And if we use a basic condition in the presence of Br2, the product will be this compound. S, it will be attached to S. And then those S, they will be attached to their alkyl groups. Okay, in this case, we have ethyl. And each sulfur is going to have 2 lone pairs. Okay, and this compound, it will be disulfide. Now, through oxidation of thiols, we managed to get disulfide. Okay, so through oxidation. Now, if you take disulfide and reduce it, you can turn it back to thiols. So reduction of disulfide, it will give you this product. And you will get 2 moles of that. Okay, if they are not identical, say for example, we have this S attached to S, and now here we have say such a compound. And if I reduce this one, and say reduction, I will get the first product will be this one, SH, and the second product, it will be this one. SH. So it will be the isopropyl version of it. Okay. And the first example, they were symmetrical. The second, non-symmetrical. Okay. Now we said that the thiols are analogs of alcohol. And now if we take the hydrogen that attached to thiols and replace it by alkyl, we get sulfide. And the sulfides, they will be analogs of ether. So the way I name, for example, this compound, I have two substituent, and both of them are ethyl groups. So I'm going to say I have diethyl, okay, diethyl, and then I use this term ether to name the compound. So ether, when we have oxygen bridge between two carbons, we can use the same the same methods to name disulfide. So in this case, we have again we have two ethyl groups. So I'm going to say this one, it will be diethyl. Okay, but because I have sulfur instead of oxygen, and I'm going to name it sulfide. Okay, instead of oxygen, we have sulfur, so we say diethyl sulfide. Okay, and we also, when we were talking about ether, and we said we can treat the ether with the one that has so with the alkyl that is a smaller, we can treat it as a substituent and call it alkoxide. Okay, and then so alkoxide group. And so I can do the same thing with the with the sulfur. And for example, on the left side, I'm going to have 1, 2, 3, and 4. I have chloro, 2 chloro, and 1 methoxy group. Chloro will get a priority, so I'm going to call it 1 and 1 dichloro. Then I say on the fourth one, I have methoxy. Okay, methoxy, and then I say cyclohexane. Okay, so this is going to be the name for this compound. Let's call it number 1, and this one we're going to call it number 2. So for molecule number 1, that's going to be the name for it, and for the molecule number 2, or the second one, again, we're going to say starting from here, 1, 2, 3, and 4, and so priority again is going to go with chloride. So simply just copy paste this, or we can rewrite it. We go 1 and 1 dichloro, and then we say 4. Okay, and instead of methoxy, now we will have methyl thiol, and then we say cyclohexane. Okay, so as you see, I treated the entire of this as one substituent. So I said methyl thiol, okay, similar to methoxy. The methyl with oxygen, we called it methoxy. So now I'm calling this one methyl thiocyclohexane. Okay, and sulfide can get involved in SN2 reaction, and through that one you can turn it to forgive me. The sulfide can be generated. Okay, can be generated by using thiol. If we take thiol and treat it with a strong base, we can take the HF from it, and we will have sulfur with a negative charge. And that sulfur, it can get involved in the SN2 reaction. And this species, the one with the negative charge, we call it thiolate. Thiolate is similar to alkoxide, and it can get involved in SN2 reaction. And the reaction, it will go forward through inversion with the stereocenter, and we get such a product. Okay, so we get disulfide plus salt, and this one in this case is going to be sodium with whatever the X is, if it's a chloride or bromide, and then it will be sodium chloride or sodium chloride or sodium bromide. And this is going to be the end of this lecture, and thank you very much.